R is the region in the first quadrant, bounded by 8 minus 3 halves, the x-axis and the y-axis, which is the best approximation of the volume of the solid if we revolve around the x-axis. So first thing I'm going to do is graph it. That would be my graph. The red line is 8 minus x to the 3 halves. It is the shaded region bounded in the first quadrant, so let's kind of look at what that means here. Oh, give me a, there we go, file. It's going to load eventually. Okay. So there's my shape. We are looking for the region bounded in the first quadrant. So if I'm looking at this one here, I'm looking at this shape up here. That's the shape that's bounded. We're revolving around the x-axis. So we're taking that shape and we're going over this line. That's the line we're dealing with right there. We got to revolve over that line. So that means I'm taking that shape and I'm flipping it down. So in other words, I'm taking this right here, and I'm going to take it and I'm going to flip it. I'm revolving it down over that axis. So it's going to end up looking like that shape. All right? It's not going to be a washer because I'm only revolving one line. It's really only going to be a disc. I'm going to take that line and I'm going to draw a washer here, or not a washer, I'm sorry, a disc from the top line to the bottom line. So my disc is going to go from here. No, sorry. It's going to go from here to there. That's where my discs are going to go. We're going around the x-axis, so that means my discs are going to be stacked from the left to the right. I'm going to start my discs over here, and I'm going to pile them up, pile them up, pile them up until I work all the way down my shape. Visually, does it make sense what we're doing? Okay, so once I've got that, now let's go back to here. So always a good picture is really going to put you in the right path to start. But now that I've got my good picture, now let's do what we're doing with that. So we know we're finding volume. So anytime we're finding volume, we know we're integrating. We're integrating the area. Our graph is going from this way, and I'm stacking my shapes this direction as I go. So I'm starting where to make my discs? I'm starting with them beginning at 0, and I'm going to continue to stack them until that spot right there, which would be what? 0 to 4. And then the other thing we want to know is those x values or y values. Those are x values. So this is a dx problem. My circles are going perpendicular to the x-axis, so that means it's a dx problem. That's the other way I can see those things. Okay, so 0 to 4, I want to know my area. If I know what my area is, I'm good to go. This is a disk problem because there's no middle section of this thing. So it's a disk here. It's this blue circle that we've drawn. I want to know the area, so it's pi r squared. I just need to know what my radius is. The radius of my circle would go from this line to the middle. This is the line that we originally drew, so that's the one I'm going to use. But I'm going from that line to the center, from that line to the center, from that line to the center. So all I want to do is that line, which is 8 minus x to the 3 halves, minus the middle line, which in this case is 0. So you can put minus 0, but obviously that minus 0 isn't going to affect a whole lot. So my answer is just pi. I can pull that pi out in front, and then we're going to go 8 minus x to the 3 halves, all in parentheses, and that whole thing is squared. That's going to be my setup here. So it's just a matter of typing that in. So we'll go math 9, or pi first, pi, and then math 9. I'm going from 0 to 4. Parentheses, 8 minus x to the 3 halves. Close my parentheses, square that thing, and then it's a dx problem. $361.9, it's E. Make sense what we're doing on that one? Racing questions?